Hello again, and let's go to the next part of the video. In this case now, we're going to use the laws that we've derived in the second part to solve some pertinent questions from the topic logarithms, okay? So in this particular video, we will basically just use the laws that we've learned to simplify logarithmic expressions, particularly when you have a series of or a list or a logarithmic expression that contains several terms and you want to combine that into a single term. We can use the laws of logarithms to do that. So we are going to try and do that in this video. The bulk of the video is about solving problems, so we have about 11 to 12 questions to solve. Let's hope this can take as short a time as possible. No matter what, I'm going to include timestamp in the video so that you can go to the particular question you want to be able to solve, right? So let's get started. So we've said we are going to use this to simplify logarithmic expressions by one, combining logarithmic terms, and secondly, by substituting letters to simplify logarithmic expressions. So we will see what this means as we move on. Yes, let's start. So this is an application of logarithms in solving, simplifying expressions and also in solving questions. In this particular case, we're just learning how to simplify logarithmic expressions. So here is our first example. All right, we can use laws of logarithms to combine two or more logarithmic terms into one. All right, let's see how we are doing this with example 1 here. The question is to express as a single logarithm the following. So we have 3 questions and we're going to look at the 3 of them together. So the first one is we're going to combine, we want to find the log of 3 plus the log of 5. That should not be very difficult. As we look at the question, we must also think about which law of logarithm is going to be most suitable to solve that problem, right? So those are 2 questions. I think I have a third one. So log of 8 plus log of 3 minus log of 6. Notice that in every question the logs are to the same base. This is not to say that in every question the logs will always be in the same base. If the logs are not in the same base, then there is something else that we can do. We can use the relevant law to ensure that they are in the same base. Okay, so in this case you notice that all our questions here, the base is the same. Okay, so question A, we are talking in base 2. In question B, base K, and in question C, we're in base 5. So what laws do we need to use to solve this problem? I'm going to put the laws here for the first few minutes, and then we will now try to work without having those laws next to us, right? So looking at the laws that we derived earlier, which laws do you think we're going to need to solve these problems? I'm urging you to maybe pause the video and try these questions yourself, and then we will proceed. Okay, assuming you've done that, we merely need law number 1 and law number 2 up there, those first 2 laws, so we are going to do away with the other laws, okay? All right, so what do we get when we add log of 3 and log of 5 to the same base? Well, clearly this is addition, so we use the product rule there, and we can simply write that this is going to be log to base 2 of 3 times 5, which is log to base 2 of 15, and that is our answer for part A. Our answer for part B is the same thing, but now the two logs, the 2 terms are being subtracted, and so the law that we need there is the second law there, the quotient law, and therefore we can write that log, this becomes log to base K of 27 divided by 9. 27 divided by 9 is 3, so the answer to this question is log to base 3 of 9, log to base 3 of 3, sorry. So log to base K. So the answer to this question is log to base K of 3, and we leave our answer like that. Okay, the last question has got 3 terms on it. Okay, the first 2 terms are added, the last term is subtracted. So very quickly you should come to know that all you need to look at is whether the term is subtracted or added. If it is added, it's going to be in the numerator. So log 8 is a positive in front of it. So it's positive log of 8, positive log of 3, but negative log of 6. So if you want to quickly simplify this, anything that is added stays in the numerator, anything that is subtracted goes to the denominator. Like here, the log of 9 was subtracted, so the 9 had to go down. The 27 is added, so the 27 is in the numerator. So we can simplify this by just writing the answer as log 2 base 5, and we put a line there, and 8 times 3, because they are positive, we multiply them, and the 6 there, because it is log minus log of 6, we subtract that, so it goes to the denominator like that, and we can see that this ends up being log 2 base 5 of, I believe we have 4 there, and so this is the answer, log 2 base 5 of 4, just like that. Okay, and this is how you simplify the logs like this, right? We're saying we have more terms. If we have 2 or more terms, we can combine them together to end up with a single log like that. So express as a single log, that becomes log of 15 to base 2, this becomes log of 3 to base k, and this becomes log of 4. All this just ends up being log of 4, log of 4 to the base of 5. Okay? Okay, let's look at the next set of questions. A2 says express as a single logarithm. Once again, we'll see what we need to use here. So we have 2 log to base 5 of 3 plus log of 6 there, everything base 5. We have a half log of 9 plus 2 log of 3 minus log of 2. In this case, the base is 3. So once again, if the bases are the same, we simply need 2 laws really. In this case, we're going to need 3 laws here. Can you think about which laws we need to use in order to simplify this problem? Okay, what I want you to notice is that the log now has a coefficient. So that means this is appearing twice. This is a half of this log here, and this is 2 log. So the log, some of the terms have got coefficients, right? So if some of the terms have coefficients like that, then we need to invoke the use of law number 3. The law number 3, where you can transfer the 2 to the top there, so that's a power of 3. So this becomes 9 to the power of a half. This becomes 3 power 2 there. You can move this up there like that. And so looking at our laws, which ones do we need? Clearly the terms are being added here. Here they're being added or subtracted. So we definitely need the first law there and the second law there. And because some of the terms have got coefficients like that, we need the third law that allows us to move that n so that it becomes a power like that. Okay, so those are the laws that we need. And I wouldn't be surprised, already I can see that we are also going to make use of that 4th line there. You may not be able to see it now, but it is coming out. It's going to be there, right? Because some of the terms are going to turn out to be log to base 3 of 3. I can see that there somewhere, and so on. So it might end up that we do that. So let's see what happens with these questions then. All right, so we need those laws, but of course, like I say, that 4th law, the rules there are going to become useful. Let's solve these problems. So the first thing I want to do is to move the 2 up there according to that 3rd law there. And so I will write here, I can write log 2 base 5 of 3 squared, right, plus log 2 base 5 of 6. Okay, after that that's 9 there, so it's log 2 base 5 of 9, log 2 base 5 of 9, and it is plus log 2 base 5 of 6, and since we are adding the logs, we multiply the exponents, and this ends up being log 2 base 5 of 9 times 6, which is the same as log 2 base 5 of 54, I believe. 9 times 6 is 54, so log 2 base 5 of 54. All right, so that is how we solve that particular question. Let's see the next one. So notice how we've made use of law number 3 there to turn that from 3 to a 9. Okay, similarly, the same thing is used here. If I put this half here, I get 9 power half. 9 power half is the same thing as the square root of 9. Okay, let's write it down. So for the second one, I will have log 2 base 3, so log 2 base 3 of 9 power half, which is the same as the square root of 9. I can do that here. So 9 power half is the same thing as the square root of 9, which is positive or negative 3, but we can't have the logarithm of a negative number, so we will take the positive value, which is 3 there, like that. And so this is already log of 3, as we can see, and this is going to be plus log of 3 squared, which is 9. Okay, let me not skip steps there, let me just go slowly. Okay, so log of 3 squared, and the next one is going to be minus log 2 base 3 of 2. Okay, so that becomes, that is square root of 9, log of 2 base 3 of the square root of 9 plus log, now 3 squared is 9, minus log 2 base 3, this is base 3 of 2. So that is of course log 2 base 3, 3, this is going to be 3, and then it's plus 9, so that we can put this together and we have 3 times 9 over 2, so it is log 2 base 3 of 27 over 2, like that. And that is our final answer. Okay, of course I had to put all those number of steps, otherwise it should be possible to see this directly and write down the result right here at this level. Okay, all right, next question. We can use the laws of logarithms to remove logarithmic terms from an expression. So we can use the laws to turn a whole logarithmic expression into just a single number, okay, without the logarithm term appearing on it. Okay, here are examples. The first one, example A3 there says, express without logarithms. And the first one is log 2 base 3 of 1 over 9. The second one there is log 2 base 8 of 64. Log 1 plus log 2 base 2 of the square root of 256. Okay? This time we will not put the laws there, but we will. I'll ask you to think about how to make use of the laws, right? Now, whenever you see numbers like 64, 8, 16, 32, 64, 128, 256, which is here, 512. What I want you to think about is computer memory, right? In computer memory, like memory chips or memory cards and so on, they always go in terms of 8, 16, 32, 64, 128, 256, 512, and 1024, and so on. Okay? So if you think of it this way, then you will always remember that these numbers, computer memory, is always given in base 2, which is to say 8 can be expressed as 2 to the power of 3, 16 is 2 to the power of 4, the next one is 2 power 5, 2 power 6, 2 power 7 is 128, 256 is 2 to the power of 8, 512 is 2 to the power of 9, and so on. So if you can keep that in mind, it means questions like this can be solved a little faster than normal, okay? You also know the memory chip that is 256 gigabyte, for example, right, from ScanDisk. So if you think like this, some of these will usually be easy to solve, and they appear a lot in questions related to logarithms and related to exponents. Okay, so how are we going to solve this? Let's see. All right, so there are the laws again. Which ones do we need here? Clearly, we're going to need law number 3 there. And perhaps you notice in the previous question that we indeed made use of law number 4 there. But let's see. So how do we make use of these laws to solve these problems? We are going to need those 2 laws there. Okay, so let's go ahead and solve this. So this one, the first thing you want to do is to express this with the 9 in the numerator. So we can express 1 over 9 as 9 to the power of -1. So I can write this here. Yeah, so of course you pause the video, try it out before you see my solution, but I'm assuming that you always pause to try the questions out yourself before you proceed. So the first one there, like I said, we can express this as log, okay, to base 3 of, instead of 1 over 9, 1 over 9 is the same as 9 to the power of -1, like that. Okay, and now I can also express this as the 9 itself is 3 squared. So I can write this as log 2 base 3 of 3 squared, but it is power -1. Okay, so by law of exponent that becomes -2. And then I can use my law here, the power law there, to move the -2 in front, and I have -2 into log 2 base 3 of 3. And now I can go ahead and use the law up there. The log 2 base a of a is 1. So all this thing here is just 1. So this is -2 times 1, which is -2. I have expressed the log 2 base 3 of 1 over 9 without using, without logarithm being on the expression. So that is what this question is asking me to do. Okay, let's try the same with question number B. All right, question B says we want to express that without logarithms on it. This should be obvious because I can express log 2 base 8, log 2 base 8 of 64. All I need is to express this 64 as a base of 8 because I'm thinking about that law there. So I can write this as 8 squared, in which case I have 2 from law number 3 there. I can move this to the front, and I have log 2 base 2 log 2 base 8 of 8, and log 2 base 8 of 8 according to this law there is the same as 1. So all this is just 1. So therefore 2 times 1 is 2 is my answer to part B. Okay, similarly in part C, all right, I have 1. So the first term there is 1, and it is plus log 2 base 2 of the square root of 256. So I'm going to write this as log 2 base 2 power 256. That is square root. That means this is power half. But 256 can be expressed as 2 to the power of 8. I'm choosing 2 to the power of 8 because I'm seeing base 2 there, and I'm thinking about that law there. So I can express this then as 1 plus log 2 base 2, log 2 base 2 of 2 power 8, but this is power half, which is 1 plus log 2 base 2 of 2 to the power of 4, right? Going very slowly, otherwise you can actually see it right from here. Well, this is 1 plus 4, so I take 4 to the front according to law number 3 there. This is law number 3. So take the 2 to the front, so I have 1 plus 4 log 2 base 2 of 2. Well, log 2 base 2 of 2 is 1, so I have 1 plus 4 times 1, this is 1. So then it's just 1 plus 4, which is 5. Okay, since this thing here, this bit there, is equal to 1. So it's basically just 1 plus 4, which is 5. I have expressed that number, or that logarithmic expression there as a number that does not have logarithm on it, and I did not use a calculator. So in questions like this, you do not use a calculator. There will be cases where you must use a calculator to arrive at your answer, okay? But you are likely to meet exam questions like this where you're asked to simplify and express without logarithm, and a calculator is not permitted. So this would probably be in paper 1 in the IB diploma program. Okay, let's move to the next. All right, example 4, A4 if you like. Express without logarithms. Okay, now of course I want you to pause the video and try to solve this without my help, and then check the solution to see if it matches mine. This time you have to think on your own which laws we need to be able to solve this. Okay, try it out and then check. All right, assuming you did it, let's see what we do with the first one. I'm going to try to be a bit faster so you can check out what we are doing. So this becomes, the 2 will go up there, so it becomes log to base 12 of 9. So I'm going to write the first term there becomes log to base 12 of 9, because the 2 goes up there and we have 3 squared. Then we have plus log to base 12 of 8, right? And the last one is minus log to base 12 of 6. Now, using law number 1 and law number 2, we can combine those into 1. If it is added, it will be in the numerator inside the argument, and if it is subtracted, we will put it below, right? So this becomes log to base 12 of, into bracket, I have 9 times 8 over 6. 9 times 8, I think, is 72. 72 divided by 6 is 12. So this is the same as log to base 12 of 12, which is just 1 according to the law number 4. Okay, the unity law says that the log or log to base a of a is always equal to 1. So log to base 12 of 12 is 1. So all this expression just reduces to 1. Okay, it means 1. Okay, there is the second one, question B there. It's been done nicely for us. So this becomes, everything is, so notice this is base 3, but this is base 5, and this is base 2. But that doesn't make life difficult at all. In fact, I don't have to, since I can't add them together like this when the bases are different. It is not possible to add them. For us to add or subtract them in this form, the bases have to be the same. So in this case, we cannot. But there is something nice that I see there. That is base 3, and it is 3 squared. This is base 5, and it is 5 to the power of 4. This is base 2, and it is 2 to the power of a half. And that is beautiful in the sense that I can use the law for the power law to move the 2 to the side. So I can write this as 2, right? Log to base 3 of 3. And I can say minus, I can move the 4 to the front, and I have 4 log to base 5 of 5. And I can move, remember this is 2 power half, so I can move a half to the front, and I say plus a half log to base 2 of 2. Please check and be sure you understand where that is coming from. And now clearly log to base 3 of 3, this bit here is 1. And log to base 5 of 5 is 1, right? And log to base 2 of 2 is also 1. Right, let's look at the next set of questions. Question 5 says simplify, just simplify. Okay, now there is something about this question that we have not seen before. What we are seeing now is a case where the base is larger than the number. So the base is 100 and the number is 10. Okay, the next question there, which law do we need now to use? So whenever you see this, whenever you see that the base is larger than the number itself, or if the base is given in the form of a square root or a power. Suppose the base was, say, 2 power 3 or the square root of 7 or something like that, then the best way out is to, so there are several conditions under which you will think about this. The base is bigger than the number, or the base is expressed as some 2 power 3 or the square root of 2 and so on. If you have a situation like that, then what you want to do is to consider using the change of base, okay? So in this case, the best thing to do is to change the base. That is to say, express this term here as log to some base of 10 divided by log to the same base of a. And the base I'm choosing is a base that is less than 100, and I know it's related to 100. So that's going to be base 10, okay? Let's see. And so, if I write this here, if I express this as log of the 10, this 10 here, divide by log of 100, this 100 here. So now I choose a new base, and I'm choosing base 10 intentionally, because base 10 is going to make the numerator, this thing is going to turn into a 1, and the denominator is base 10. If that's base 10, I can write this as 10 to the power of 2. Okay, so this becomes, I can write this as 1 over log to base 10 of 10 squared, and using law number 3, I can write this as 1 over the 2 goes in front, so 2 log to base 10 of 10, and log to base 10 of 10 is 1, and so my answer is clearly just 1 over 2. Okay, so I've reduced log to base 100 of 10 as simply being a half. Okay, let's see the next one. Okay, question A6 there, simplify just like before. Please pause the video and see how question B looks like. Log to base 27 of 9. Once again, you can see the base is bigger than the exponent. So once again, change the base. Okay. Obviously, the best base to use there is base 3. And you must think about why I'm saying the base 3 is the most useful one. Because both 27 and 9 can be expressed as under base 3. Okay. So once again, assuming you've paused the video and you've tried this out, as I would expect you to do, I will write that as being equal to, I'll write log of 9, divide that by log of 27, like that. So log 9 divided by log of 27, I'll change the pen. Log 9 over log 27 there gives me, I can express log of 9 by the way I choose the base that I want. So I've decided that I'm going to use base 3 because I know both 27 and 9 can be expressed as 3 to the power of something. So this is of course log to base 3 of 3 squared over log to base 3 of 3 power 3. And this becomes, by law number 3, I can write this as 2 log to base 3 of 3, everything divided by 3 log to base 3 of 3. And log to base 3 of 3 is 1, otherwise you can cancel that with that, and I end up with 2 over 3. So the answer to this question is 2/3, like that. Yeah. Let's see another one. Do get into the habit of pausing the video and trying out the questions before I actually start solving it. So even if I don't say so and you see I've put up a question, try to pause the video and do it yourself and then compare what your solution is with mine. Let's see the next one. A number 7, simplify. We have log to base a power 5 of a. So notice that a power 5, the whole a power 5 is a base, and it's base of a. So once again, we can see that there is some complication with the base there, either bigger than the a there, or it is complicated in that it's a power or it's a square root or something like that. So the best way forward, as before, is to change the base. So I'm going to change that to, now it's base a power 5, so I'm going to change to base a alone, right? So express that as log of the a, the number itself, divide that by the log of a power 5, and then we choose the base that we want this to be in, and I'm going to choose, I've decided to choose base a, obviously. So I'll say base a here and base a there. Okay, that means that the numerator is already 1, and the denominator by law number 3, I can move the 5 back there, and I have 5 log to base a of a. Log to base a of a is 1, and so this reduces to 1 over 5, like that. Okay, so my choice of the base must be well considered. You can put any base, but not all of them will help you reduce the expression as you want. So always choose the base wisely, thinking of the numbers or the bases that you have available. Okay, let's look at the next one. Was there A6? That was A7. Let's look at A8, and this says, yes, simplify this. Is there a way to write it so that there is no log on it? I doubt it, but let's see. So we have log, simplify. It doesn't say it without log on it, but we can simplify it, right? So we can already see that the base that we have there is the cube root of b. So the whole thing there, cube root of b, is a base, okay? That might make some students think this is difficult, but really it isn't. Same story. So I'm going to write this as log of the number over log of the base. So log, I'll write this as log of the number, which is 3b, divide by log of the base, log of cube root of b, which means b to the power of 1 over 3. I'm assuming that you've done rational exponents like that. So cube root of b is the same as b to the power of a third. Square root of b is the same as b to the power of a half, and so on. And so I can write this as this is multiplied. So from first of all, I need to choose the base that I want to use. So I'm going to choose, intentionally, I'm going to choose base b because I can see what's going on. All right, so I put b there and I put b there. I should have used a different color, but I hope you will see it. And so now the numerator can be expressed as log to base b of 3 plus, because it's been multiplied, so law number 1 plus log to base b of b, right? If we are multiplying the numbers, we add the logs like that. And the denominator becomes 1 over 3, law number 3, log, also the power law if you like, log to base b of b. So we can already see this remains log to base b of 3, but plus 1. And in the denominator, I just have a third. Okay? So if we are dividing by a third, this, because this is 1 over 3, the 3 can go up. So in fact, my answer then is, we can show this. I hope I don't have to, but this is the same as saying log to base b of 3 plus 1, and we are dividing by a third. So if we are dividing, then we are multiplying by 3. Okay, so this is flip, change that to multiplication sign and flip this, it becomes 3 over 1. So effectively we are multiplying by 3. So I can write this as 3 log to base b of 3 plus 3, and that's my answer. I could write this, of course, as log to base b of 27, because the 3 here can go up, right? And I say plus 3, and this is the best I can do. Either leave it like this or I express it that way. Okay? I'm hoping that's fine. Let me know if I need to say something extra or if I need to slow it down a bit. Okay, so that is done. Let's go to 9. What does 9 say? Now we are going to remove, we're going to simplify expression by removing logs and replacing with some unknowns, okay? So given that, so we can use laws of logarithms to remove logarithmic terms from an expression, okay? So given that the log to base a of 2 is p, and the log to base a of 3 can be represented by q, and the log to base a of 5 can be represented by letter r. Express the following in terms of p, q, and r, okay? So either p and q, p and r, q and r, or all three. Express the following that way, okay? So can we express log to base a of 10 so that it is in terms of p, q, and r? This is very common in the SL papers, okay? IB mathematics, SL questions. So in order to do this, it means we have to find a way of expressing 10 in terms of 2, 3, and 5, or at least 2 of them. So clearly you can write this. We can write the 10 there, the log to base a of 10 as log to base a of 2 times 5. So 10 is 2 times 5. I'm writing 2 and 5 because I see log of 2 and I see log of 5 there. All right? And so this can be expressed using the law number 1, the product rule. This is product. So the product law tells me that this is log to base a of 2 plus log to base a of 5. But log to base a of 2 is p, and log to base a of 5 is r. So I can therefore express this simply as p plus r. So I have reduced log to base a of 10 simply as p plus r. I hope you can understand that. It's really that simple. Let's see another one like this. Okay, a10 log to base a of 0.3. So if we're going to solve this, then 0.3, it must be possible to express 0.3 in terms of 2, 3, and 5, or at least 2 of them, or 1 of them, right? So, well, clearly, log to base a of 0.3 can be expressed as, I hope you paused the video and tried it out. Yeah, assuming you've done that, I can write this as log to base 3 of 3 over 10. 0.3 is 3 over 10, which is log to base 3 of 3 minus, because we are dividing, because it's a quotient rule, so we subtract, log to base 3 of 10, which we already know is 2 times 5, like that. So then this is log to base 3, or log to base a, sorry, is it? Log to base a, not log to base 3. So I'm just going to change this here. This is base a, that is base a. So we'll change this. This is log to base a, that is base a there, and this is base a. So this is log to base a of 3, which you already know there is q. So that's already q, minus log to base a of 2 times 5 is log to base a plus log to base a of 2 plus log to base a of 5. We've done this already, and we found, if you remember, let me just do it. So this is log to base a of 2 plus log to base a of 5. Notice I had to put a bracket there so that I keep the negative sign out there. And now this is just q minus into bracket log to base 2 of that is p plus r. Or you can write q minus p minus r like that, and that is our solution to that problem. Okay, so we are almost done with these questions. Let's see what's next. A11. Okay, simplify log to base a of 30. All right, so we are going to write that in terms of p, q, and r. Pause the video and try it out, and let's see what you come up with. Otherwise, 30 is clearly, we can write 30 here very quickly. 30 is the same as log 2 base a there of 30 is 5 times 6, and 6 is 2 times 3. So I can write this as 5 times 3 times 2, or 2 times 3 times 5, doesn't matter, that's 30. And this is therefore log 2 base a of 5 plus log 2 base a of 3 plus log 2 base a of 2, which is simply, what's that, r plus q plus p, or p plus q plus r, doesn't matter which you start with. So that's quite easy. The last one here needs us to think a little. You need to remember the stuff we've learned in, this is a recurring decimal here, so you have to think about how we found how we change the recurring decimal into a fraction. So pause the video and think about how to solve this, and then we'll see you in the after you've done it, okay? So to start with, I'm just going to change that recurring decimal into a fraction. So as we did, we say let r be the recurring decimal 0.5, that which means 0.55. That line means recurring, so 555 like that, continuous. Then multiplying by 10 gives me 10r becomes 5.555 recurring. If I subtract the second expression from the first expression from the second, that means 10r minus r, I'm left with 9r, and this minus that leaves me with 5. I hope you understand. 10r minus r is 9r. 5.555 recurring, subtract 0.555 recurring, takes out all this, I'm left with 5. Divide both sides by 9, and I'm left with r being equal to 5 over 9. So effectively, that is the same as log 2 base a of the square root of 5 over 9. So I can come here now and say, right, so keep this in mind, I'm going to write it here. Okay, so we found the recurring decimal is equivalent to 5 over 9. So I'm going to write this here as, so I'll write this is equal to log 2 base a of 5 over 9 power half, which is the square root. And so I can move that to the front, and I have a half, that is according to law number 3, or the power law, the half can go in front, and I'm left here with log of log 2 base a of 5, and because we are dividing, I can say minus log 2 base a of 9, but 9 is 3 squared, like that. So I can write this, okay, can I use the space here? I can write this as a half log 2 base a of 5, okay, and this 2 goes in front, and then a half comes forward, and I have minus 2 over 2 log 2 base a of 3. So that becomes a half. The log 2 base a of 5 is r, so a half r minus 2 over 2. 2, remember the 2 came from here to the front, and then the half opened the bracket and we brought it here, so we have 2 divided by 2 there, so that's just 1, and log 2 base a of 3 is q, so this just becomes a half r minus q, and that's our answer for this question. I hope you got it. Let me know if I need to do anything else to help you understand this solution. Right, I believe that this brings us to the end of this video, but I've put some questions here for you to try and see that at least you get you know how to go about these questions. So just take a look at these questions. I also put the answers there, so try them out and see that you can get them, and the answers are given. So express as a single logarithm. Here are some questions, so find that out. Question B is given there, question C, question D, and I think that was the last one, a little longer. Please try to express those as single logarithms, okay? You can pause the video and try them out, but once you have completed doing them, these are the answers I expect you to get. So before you see these answers, I hope you can pause and try them out. So the first one there, if you get it right, it should be the log to base 4 of 14. The second one should be the log to base 2 of 3p squared root q. Okay. The next one, the question D, is going to be log to base n of ab power 4 over c cubed. And the last one, I've put it up there, it simplifies to log to base a of a third. So try these questions out and see if you can get them correct. All right. This will bring us to the end of this lesson, and we will continue on to the next one. So this was lesson number 3. In the next lesson, we will be looking at additional different types of problems, including how to expand or how to decompose. So what we've been doing is we've had several terms and bringing them together into one term. What we want to do is, what happens if you're given one term, we should also be able to split them into several terms. So we say we need to be able to decompose a logarithmic expression. So that is going to be the next video. And then after that, we will also do questions related to solving logarithmic equations. Okay. We can also use laws of logarithms to solve exponential equations. So we will see how to use laws of logarithms to solve both exponential equations and logarithmic equations. Okay. All right, before I go, let's just recap what we have done. We are saying that we have used the laws of logarithms, these particular laws of logarithm, to simplify logarithmic expression either into a single logarithmic term or to solve it to a single number, all right, to evaluate it into a single number. So these are the laws that we've used so far. So that's the product law. We've used the quotient law, and we've used the power law. I believe we've also used the null value rule as well as the unity rule. And in the next video, we are also going to be able now to make use of the change of base. We've done change of base here, but we've not done many questions that are really difficult that require proper use of the change of base. So we'll use the change of base and also the subsequent rule involving a function and its inverse. Okay. Thank you very much. Once again, if you're seeing this for the first time, or even if you're coming back, please consider sharing the video widely, click the notification bell, and share widely so that others who might need these videos may be able to make use of them. Thank you very much. I'll see you in the next video.